Okay. So what is thermodynamics? Why is it important? Okay.
To
So
measure heat like that, sir.
heat.
Heat of a reaction.
Thermo means temperature. Dynamics is the change, the heat
Yes, sir.
changes, dealing with the heat change. So why is it important? What is the reason that we are studying?
To say whether a reaction is going to happen or not, sir.
Exactly. So it helps us to identify whether a reaction will take place or not, given the conditions of the temperature and pressure. So at this temperature, will a reaction take place? No, this temperature reaction will not take place. And will this reaction need more pressure? Yes, of course, it needs more pressure for the reaction to be carried out. Otherwise, the reaction is not going to be carried out.
Yes,
That's
sir.
number one. Number two, how far the chemical reaction will happen, the extent to which the chemical reaction will take place. Will it burn completely? Is it going to burn completely, or is it the reaction will not take place after some time? The extent. The second thing is the extent. The first one is the feasibility of a reaction. The second one is the extent to which a reaction will take place. And third thing, identify the force. Are there any chemical forces? Identify the force which is needed for the chemical reaction to take place. We see what they are.
Yes, sir.
And also help us to come up with the laws related to distribution and chemical equilibrium. Distribution law and among several others, these are some that we will be seeing. And chemical equilibrium. Law of chemical equilibrium. So these are the some of them, the main reasons why it makes thermodynamics an important study for us to understand, to predict whether these reactions, any reaction is possible, or to what extent, what are the forces involved, and to understand the laws of distribution and the chemical equilibrium. Before getting into the details of all of these, we will try to understand what some basic terms which are involved that we need to understand what they are. So we're going to see we quite often use the words called system. We will be using the word surrounding,
Boundary.
and we will also be using the word boundary. What are these things? What are we referring to these when we say system, surroundings, and boundary? Right?
Yes, sir.
Okay, so system. So anything in the universe. We are not talking about a confined place in a room or something like that. We are talking about the entire universe. So the part of the universe which is under an observation related to thermodynamics is called can be called as the system.
Oh, yes,
So
sir.
any part of the universe which is under a thermodynamic observation can be referred as a system.
Yes,
So
sir.
we are going to study about it, the entire thing, how it works. So the whole thing can be called as a system. This is nothing but part of the universe. So then, what is the surrounding? So anything other than the system that is going to interact with it is called the
Surround.
surrounding. Other than the system, and that interacts with it is called surrounding. So then what is called the boundary? So boundary will be an imaginary line, can be imaginary line or a real line or a surface. Any real or imaginary surface which separates the systems from the surroundings. So when we say system, it can be one system or it can be group of systems as well. So if they are separated from the surroundings, the system from the surroundings, it can be called as a boundary. Similar to we have in the cricket field, the boundaries. The ball reaches the edge separating the gallery.
Yes.
You hit the ball. We call it as a hitting the boundary because the gallery separates the field. Okay, so now some important thing about the boundary. The boundary is of two types. One, it can be diathermic boundary. Diathermic. Diathermic means passage of heat is allowed.
Not insulator.
Exactly. Is allowed. The heat can pass through the boundary. Just like the ball reaches the gallery from when six is hit, right? That's it's an open ground or something like that. You hit the six, it crosses the boundary. The ball can pass from the other side, and the other side they throw the ball back to the field. And the other one, adiabatic. Called adiabatic boundary. So what is this adiabatic? The opposite of
Heat will be constant, sir.
no passage of heat is no passage. So
Sir, on a work motto class house.
work motto cross out. We'll go step by step. Right? So understood about these, the differences,
Yes.
right? And the basics, the terms, what they mean and all that. Perfect. Next we will talk about the systems. So we saw about the boundary. Now we will see what the systems are. So just like the boundary, two types of boundary, we have systems are also of different types, depending upon the movement of energy or matter. Okay, movement of energy or matter. If according to the movement of the energy or the matter, in and out of the system, it is categorized into the following types. First, it is called open system. The first one is an open system. So, what is an open system? An open system is one where the matter as well as energy is exchanged with the surrounding. The matter or energy is exchanged with surrounding. It's called
Open system.
an open system. So, open field, cricket field, soccer field, so all these things, the boundary is not sealed and it is not insulated. Okay. So we can imagine these boundaries as imaginary. Okay.
Yes.
So yeah. So let's say if we keep a reactant, two reactants are inside a beaker. We have A and B in the beaker. This can be considered as an example for an open system.
Yes, sir.
Similarly, all reactions taking place in human systems, in human or on not human, let's take living systems. So what are the reactions that will take place in the living systems?
Digestion, respiration.
Very good. Right. So those are also coming under open system.
Sir, this will be closed, no, sir, this digestion and all.
Closed exchange of gas, breathing, respiration. You said, are we closed anywhere?
Materials will not get exchanged, no, sir.
Surrounding digestion, secretion is happening. I mean, the secretion of the gastric juices, the enzymes being secreted, and then they act upon the carbohydrates. Breaking down is happening. So the system is not closed. Always the exchange of gas is taking place. The surrounding is this system is not isolated,
Okay, sir.
and the heat, the exchange of heat is happening. Exchange of matter is energy is taking place, isn't it?
Yes, sir.
Energy exchange is taking place. We can never say that there is no energy exchange.
Yes,
Right, the matter is also being exchanged from one organ. It is transferring, it's being passed down to the other organ. Digestion, I mean, the things are being taken, I mean, forward from one to the other, isn't it? The continuous flow of energy, exchange of matter and energy is happening inside this, so it cannot be closed one or anything.
okay, sir.
It's an open system. Similarly, even car engines are also exposed, just like the respiration, exhaustion, combustion,
Yes, sir.
right? Car engines. And we can keep saying like this. All examples of open systems. So in this case, there will be change of mass. Delta M will be not equal to zero. Delta M is what? Change in the mass.
Yes, sir.
The change in mass is not zero, which means there will be change in mass as well as there will be change in energy. So both
Yes.
of these things are not going to be zeros. So when they're equal to zero, what does it mean? The system is constant. There is no
Yes.
change in mass and there is no change in the energy, which is not the case.
Insulated system.
Yes. Right. So this is about the closed open system. So if there is something called as an open system, we need to have something called as a closed system as well.
Yes, sir.
So let's look at what is a closed system. So in a closed system, there is no exchange of matter with the surroundings. Okay, two things. No exchange of matter with the surroundings, but what was Sriram saying? There
Energy
will
gets
be exchange.
exchanged.
Energy exchange is there. Energy exchange takes place, right? So, such as it can be in the form of heat. The heat exchange is possible.
Yes.
Work exchange is possible. When you say heat, even radiation is also possible. Okay.
Sir, how work is possible, sir?
How work?
Work is something we are applying on the thing, is no, sir.
Yeah, we will see that.
Okay.
Close system. So, let's say, what happens in a balloon filled with helium? What will happen to that balloon? It is sealed. Once it's
It
filled,
will fly, sir.
it will move up, isn't it? It
Yes.
keeps moving up. Can we say it is a closed system? But still, the work is there is no matter exchange, but work happens,
Yes, sir.
isn't it? So in this case, no exchange of matter. So Mass change in mass is zero, whereas energy exchange in energy takes place. That is not zero.
Yes, sir.
Make sense?
Yes, sir.
Then it is a closed system. So then what is an isolated system? Next one is going to be
Both
the
are equal to 0.
isolated system that is completely isolated from the surroundings, from another system. So no matter, no exchange of matter as well as
Energy.
energy. Yes. No exchange of matter and no exchange of energy, which means my delta M is also
0.
0 and delta E is also 0. Okay. So example for this will be thermos flask. Thermos flask can be considered to be an isolated one where the temperature is maintained. There is no exchange of heat. There is no exchange of energy also going to be there in that. Okay.
Yes, sir.
Next, we will see what is some of the properties at a macroscopic level. See what are the macroscopic properties related to thermodynamics. What is it? So the macroscopic properties. Now, the physical quantity associated with the state of a system is called as a property. Physical quantity, such as density, mass, volume, you're saying, right? Physical quantities which are measurable.
Yes, sir.
Right? So physical quantities which are used to define the state of a system. Define the state of a system is referred as property. So what are we talking about? The macroscopic property. Okay. The thermodynamics, if we see, it deals with bulk matter. What do you mean by bulk matter? Bulk, as in, it is not going to take place at a microscopic level. We are going to see it at a macroscopic level. That is anything in excess.
Yes, sir.
Excess quantities, large quantities, right? Which is visible. So those properties which arise as a result of this bulk behavior, that we call it as. So anything which is bulk in nature, deals with bulk in nature, can be referred as macroscopic. The properties associated with that can be called as the macroscopic properties. Now these properties again are further classified as intensive and extensive properties. So what is an intensive property and what is an extensive property? If you look at an intensive property, so those properties which don't depend upon the okay, quantity or the size of matter are called intensive. So intensive are the ones which don't depend.
Yes, sir.
Okay, so they don't depend upon the quantity or the size of matter. We can call them as intensive properties. So what could be called as intensive property then? Examples, you can call pressure. You can say pressure does not depend how much amount of pressure.
Volume,
Temperature, yeah,
heat,
um, density, density of the substance, concentration of the substance.
Heat, sir.
Heat. That's the temperature, no? Huh?
Okay, sir.
Right? We can keep saying, and then we can add even surface tension. Surface tension associated with liquids, viscosity, fluids, and also refractive index. So these are all examples for intensive properties. So then, what is an extensive property?
Depend upon quantity and size.
Those which depend upon the quantity and the size of matter can be called. So the properties, those properties which depend on quantity and
Size.
size and or size of matter, we can call them as extensive properties.
Yes, sir.
Right. So volume comes under this. Volume,
Work.
density. Yeah. So when we said the previous one intensive, we mentioned the density. We didn't say the volume.
Yes, sir.
So here we can call volume and
Mass.
fixed energy, number of moles, mass. Yes, volume, mass, work. Right. So these
Work,
things
sir. Yes.
work also. Yes.
Force.
Hmm? Number of moles. Gibbs energy.
Force will come, sir.
Force, huh?
Yes, sir. Mass into acceleration.
Mass into acceleration. Acceleration. The mass is one, but if you look at the volume, one second.